Hi, and welcome back to another video. It is a sunny afternoon here in Accra. Yes, very sunny. Anyway, so the purpose of today's video is to share with you about a recent solar project that we did at a place called Bowi, which is within the Greater Accra region. So this video is to share with you how the whole installation was, what went into the installation, the cost, among a few other things. So without not talking further, let's just go ahead and then get into the video. So like I said, this project was in Gbawe. Prior to the installation of the system, the client was experiencing intermittent power supply from the grid, that is ECG. So he was looking at something as a backup for the house. So actually he doesn't live there, but he was trying to do it for the mom, because the mom is the one who stays in the house. So he was looking at a system which is going to serve as backup, so not entirely full of grid system, but something which was going to be working alongside the grid, so that in case the grid is off, then it takes over and then it serves power to the house. So I had to go by to do assessment of the whole place, so looking at the house, looking at the type of roof, looking at the kind of appliances that was being used, among a few other things. And then aside from that, also I did observe that they already had sort of an inverter system or a backup system that they were using, but I think it had outlived its usefulness, so they were no longer using it. So I did meet that, which also had an AVR to it, an automatic voltage regulator to it. So I did observe that as well. So upon doing all these investigations, then I came by the system which was going to be appropriate for them to go by. So in the house, it's a 4-bedroom house with a big living area, also has kitchen, has the laundry space, and then the storeroom, among other things. Aside that, there are some of the appliances that they did have there were the usual lights, then air conditioners. So 4 air conditioners, of course not all of them are powered together at a go. Then ceiling fans, lights, TVs, freezer. I think there was a freezer, there was a fridge, a refrigerator as well. There was a washing machine, and then also you have the kitchen appliances, that microwave, cooker, blender, among a few other things. So upon putting all these together, you also have to investigate how of them are used together, or at what point or how long they are used. So upon doing all these investigations, then I did come to the design phase. So the design phase is where you design the system. What kind of appliances are you going to use? What kind of what kind of system are you using? So in terms of the inverter, what type of inverter, what size of inverter, what kind, even a brand. And as part of that also, you're looking at the panels, what kind of panels are you using, the size of the panels you are using, also with the battery. And even with the installation or the mounting of the panels, you also have to take into consideration the kind of accessories you are using, so the clamps, the rails, among other things. So all these things were done, and then did come by the design. So for the system, or for the complete solar system we're looking at doing, or we used a 12 kVA hybrid inverter. Hybrid because they already have the grid present, and they wanted something which was going to be working alongside with the grid. So should in case there's no power from the grid, then automatically the system takes over. So that's how come we went with a hybrid inverter. Aside from that, also looking at the panels, we went with 715 watts of panels. We went with 12 pieces of it. You may ask why 12 pieces. So the kind of inverter we used, the 12 kVA, has 2 MPPT charge controllers. So the charge controllers is responsible for charging the battery, and because it has 2, if you are doing the configuration for the system, it is always best to balance the power which is coming into each charge controller. So we use 6 pieces of the panels each for the charge controller, so that gave it a total of 12 pieces. Then also we went to 715 watt because we're looking at something which is going to help charge the system faster. And then also because they were using a couple of appliances, it will also be good to have a solar system which is able to power some of the load, especially during the daytime. So the 12 pieces of the solar panels was actually a good option to go with. So the inverter, like I said, 12 kVA hybrid inverter. Then the battery, we went with a 16 kilowatt inverter. It's the same battery we are using at the car wash. So for the inverter, one piece of the inverter, 12 kVA, the battery went with one, the panels went with a total of 12 pieces of it. So we started off with the usual works, because for this particular place they were using a previous system which was serving as backup. They had already done some wiring. Even though we're not going to rely on their wiring, the kind of building they had was a secret roof. So the olden type of secret roof that used to be done, so it would have been very difficult to go into the ceiling to pass cable. So what we did was to rely on the old cabling that was done. So whilst pulling that out, we tied our cables in onto it. Now also for the setup of the inverter, there are a couple of things that we did. So the inverter has an AC input. So AC input is basically power coming from the grid, which is coming into the inverter. Now that is able to do two things. It's able to charge the battery, and it's also able to power the house. I'll come back to explain that. And then we also had AC output. So AC output is the power generated from the solar system, which is going into the house. So we had that as well. And then we also have PV input. So the PV input is the photovoltaic system, that is the panels, which is providing power to the inverter. Now that also does two things. It does charge the battery and then also supply power to the house. So that is the configuration that we had for the inverter. Now with this, doing this, it means that there are a couple of cables and the different sizes of cables that we had to use. So for the cables, for the AC inputs, you need 3 different sets of cables. So you need one 7 as live, and then you need one 7 as neutral, and then you need one 7 as it. However, for this system that we installed, because of what they were already using with the grid, they were using a 3-phase system with the grid. So 3-phase system means that they had 3 different live wires coming in. So live 1, live 2, live 3, or L1, L2, L3. So that also means that with the inverter, aside selecting the hybrid inverter, aside selecting the size, we also had to go with a 3-phase inverter. I hope you follow. So aside doing all these things, you have to be able to decide on what kind of system you have to go by. So we will use a 3-phase hybrid inverter. So 3-phase means that we have 3 different power inputs, also 3 different power outputs. That is a live, yes. Somebody may ask, why is there even a 3-phase maybe power option for homes? Now, I may not be the best person to explain this, but I'll try my possible just to explain in simple terms how I understand this. So usually 3 phases provides different power from each line. So each line has the power it's providing. Usually, sometimes some of the voltage are usually on the same, but you have instances where there's slightly differences in the voltage, but not so much wide apart. This is usually supplied to homes where there are a lot of appliances that are used, in the sense that if you have just one phase coming, it's sometimes difficult to supply all these appliances, because then you might experience some drop in either voltage, among others, where you are not able to power everything. So you have homes where you have like a lot of air conditioners, some homes even having elevators, among others. Then it's different to have 3-phase. So a 3-phase means that if you are getting let's say about 4,000 watts on each line, then you have 3 of it. That gives you a total of 12,000 watts. So then it's able to power your load. But if you have just 4,000 watts coming from one line and your demand is more than 4,000 watts, then that is not really going to serve your purpose. So that is, in a simple way, something you can look at when it comes to like 3-phase, 2-phase, single phase. So for their house, they had 3-phase meter or a 3-phase power coming from the grid. So we also had to match that with the inverter. So what we installed was a 3-phase system. So with the cables, you have 3 sets of cables. So if you have 3-phase option, it means you have 4 cables coming from the grid to your house. So you have line 1, line 2, line 3, and then you have neutral as part of it. So the same way with the configuration of the inverter is the same thing. the AC input requires that, and then the AC output is also basically that. So we have 4 sets of cables coming in, another 4 sets of cables, making a total of 8 cables. So then in addition to that, we have 2 more cables, which is 7 at 8. So the one coming in and then one going out. So 8 plus 2, that gives you a total of 10 pieces of cables. Then aside from that, you have the PV cables as well. So you have 2 coming in from each panel, that is positive and negative. And then you also have other 2 coming in. So in all, the total quantity of cables we had to pull through the ceiling was like about 12 or so, yeah. And it was easier to pull them because they already had an old system. We didn't want to mount the trunking on the wall to pass the cable, so we wanted to have a clean job. So that's how we went by that too. And then also for the cables, we use different cable sizes. For the panels, we use you have the option to use a minimum of 6 mm DC cable. So panels, they are specific or DC type of cables that are used for solar panels. You don't use AC cables for solar panels. And then also, so we use 6 mm. We could have used 10 mm, but 6 mm does also work. If you look at the calculation of the amperage that is able to carry, 6 mm was okay to go by. So we use 6 mm for that. And then also for the AC input, we use 10 millimeters, 10 mm cable. And then for the AC output, we use 16 mm cable. So we pass all these cables for the respective kind of work that they were going to serve. So after doing that, then we went ahead to mount the inverter on the wall. After mounting the inverter, we had different breakers that were doing different things, which I'll explain, also mounted on the wall. So we had the breaker boxes mounted on the wall. So we had a breaker box for the panels, we had a breaker box for the changeover, and then we had a breaker box for the AC input. Now for this inverter that we use, it already has a breaker for the AC input, but it's always best to have an additional line of protection for such systems. So for the panels, after mounting the panels, 6 each in series, passing all the cables to where they were going to go, then we installed breakers for them. So we use 32 amps breakers for each panel. So that was 2 pieces, and then also we use SPD, 2 pieces SPD. Now the purpose of the SPD is to be able to channel over any excessive power that is going to come through the system to the earthing systems. So as part of the configuration of the SPD, there's earth to earth. So you connect earth cables so that in case there's any excessive power generated from the panels through lightning or anything, then those excessive power goes or is channeled to the earth. Yeah, so that was a layer or different layers of protection we added or we applied to the panel. So we had breakers, 2 breakers, and then we had 2 SPDs. Then you come to the changeover. So the changeover, we use the breaker type changeover. There are different kinds of changeovers available. There are automatic ones, there are manual ones, among others. What we used was a manual one, but it's the breaker type. So it has 3 levels. So it has the off mode, which is the middle point. It has the grid mode, and then it has the other power option mode. So being a solar, being a generator backup, among others. So for ours, we added the grid power to the top. So once you switch to the very top, that means you're using grid. Once you switch middle way, it means you've turned it off. Once you switch downwards, it means that you are using the solar system. Aside from that, also we had the AC input breaker, which simply takes power from the grid and then takes it into the inverter. So that is just 2 modes, off mode and then on mode. So we also had that installed, and we did all the necessary wiring. Then we installed also the battery, which comes with 2 cables, positive and negative. Aside from that, also you have to connect to the earth cable from the battery to that either in the inverter or the earth system. And then also you have to connect a network cable or a communication cable, I should say that way, which helps establish communication between the battery and the inverter. It's very important they communicate so that they're able to function properly. So this was the configuration that we did in terms of the hard configuration. The cables coming in here and there, the appliances, and then the systems that we used for that. Now let's look at the different roles that each is playing. Just as I've said, the panels, breaker is taking care of the power coming from the panel, channeling it through the inverter, 7 either the house or 7 the battery, charging the battery. Then you have the AC input, which is taking power from the house and then taking it into the inverter. Now there's one tricky thing about the AC input, which is that when, just as I mentioned with the breaker, you have 3 modes: off mode, grid mode, and then solar mode. Now when you switch to the solar mode and you have AC input present, that means that you can use a combination of the grid with the solar system on the inverter. You get it? That is when you come to the configuration of the inverter. That is the soft part of it, or the software aspect, where you do the various configurations. So you have the option to do that. So as part of the reason why we added the AC input is to be able to make the hybrid option of the inverter serve its purpose. So that is why we added the AC input. Then you have the AC output, which is basically the power coming from the solar system going to the house, which is straightforward. And then also, because now you have a backup system, which is basically the battery, then also you have the power from the battery coming into the inverter. And then the size of the cable for that was, I think, 50 mm, either 35 mm or 50 mm, one of that. And then that also goes through a breaker. So for that breaker, we use 250 amps breaker, which, even though the battery also has its inbuilt breakers, just as I said, it's always best to have an additional layer of protection for some of these systems because of the cost they come with. So upon doing all these configuration, then it was time to now do the configuration on the system itself. So where you specify how you want the system to function. So as part of the configuration of the system, you're able to select what does what at what point of the day. So at this point, you have the panels, you have the battery, you also have the grid. So how do you want to use it? So what we did was that we made the panels the first priority in terms of power that is provided to the house. First priority in the sense that during the daytime, where there's daylight, there's a lot of maybe sunlight and the rest, that is going to serve power to the house. So that is going to serve power to the load. And because of the size of panels we had in total, that was able to power a lot of appliances during the daytime. So that was our first option. Then the second option is having the grid step in once the panel is not able to do that. So on cloudy days where there isn't sufficient power, especially to charge the battery or even to supply load to the house, then the grid steps in. Then also in a case where there's power outage, then the battery steps in. Now, one interesting thing I like about this system is that it does all these things in real time. So at a point in this video, you see where I was actually testing that, where I turned off the PV, then the grid takes over, then I turn off the grid, then the battery takes over. And it doesn't even go off or the light will flicker or anything. It does this in real time. So that's one thing I like about the system. I've seen people install solar system for some people, and they have to be doing things manually. They have to go and use a changeover to turn off or switch from one mode to the other. That is a whole lot of inconvenience. For the systems that we have deployed, especially for the ones that had an option of grid, we try as much as possible to do it this way so that there isn't any form of inconvenience. All these things is done in real time. And so for one system that we actually installed in the Oyarifa Park that is within the estate, this was how we went about it, and the client was so much excited about it because sometimes she'll be out going for a walk and she realized some parts or portions of the estate is dark. Then she realized that, oh, there's a light out, and she doesn't see that at her place. There's always light. Sometimes she'll be indoor and then the other neighbors are calling to find out if she's got lights and the rest. It's like, oh, it means that there's actually power outage. She doesn't experience that. This is as a result of doing this in real time, and that is being done by the inverter. So that is why it is always good, if you have a grid present, maybe you should go for a hybrid inverter which is able to do this. So that is what we did with the installation. So panels were mounted. Unfortunately, we couldn't get the panels in the best possible angle because of the type of roof that was done. So the type of roofing sheet was the single type, the olden type. So it's not like the long span alu-zinc roofing sheet, which has like top section where you're able to use a clamp. So we had to, for this, we had to screw the roof clamps to the wood members in the roofing, and also that wasn't done in a straight line, so it actually affected what we did. And then also, as part of, because we had to do the screwing, we had to also apply silicone around the screws so as to prevent any form of leakage. It's very important. So we did that. We mounted the panel 6 each in series, and then the other set of 6 also in series. And one good thing is that just in front of the house is where the sun rises from, and it sets just at the back of the house. There's an app that I use to do that, so it shows you the path, and or which direction the sun rises and which direction it sets. So it was easier to figure that out. We didn't have to struggle with where we're going to mount the panels and all that. Now, one thing, because of the level of angle the roof was at, we had to elevate a little part of the back point of the panel so as it's able to trap a lot more daylight. So we elevated that to give us a total of like about 40 degrees, which is good for solar panels installation. So we did that for both for the front part and the back part. Now we were able to do this with a special type of clamp that we use. Now, talking about all this, I must say that all these products were supplied by SunSum Solar. Yes, we bought all these appliances from SunSum Solar, from the inverter, the panels, the breakers, everything. So in case you are looking out to start or install a solar system, I highly recommend them. And the reason why I recommend them is that it's always easier to get everything. So a one-stop shop for everything. And aside that, also they provide support in case you have challenges installing the system and the rest. They always provide you with support. So that is just by the way. So in case you need a solar system and you want to do it by yourself, or you want to buy your own appliances and the rest, kindly reach out to them using the number on the screen, and I'm sure they are going to be able to meet your needs. Do well to tell them that you actually saw or heard about them through my video, and maybe you may get a discount for whatever you may be buying. Yes, so that is how we went about the installation of the panels. Now, among all these things that I've mentioned, I actually haven't mentioned the brand that we use. So the brand is SRN. So for the inverter, SRN. The battery also was SRN brand. That's what we use. It's always good, like I've always said, to have one consistent brand so that it's easier for them to communicate among themselves. Because as part of the configuration you do on the inverter, you have to specify the battery type. You have to also specify the brand. And it makes it easier for communication, seamless communication in between the system. So this was how we went about the system. We did all this, and it was time to now test the system to make sure everything was well. Then we ran into a problem. Yes, a serious problem, which took us a while to resolve. So what happened was that after doing all this, you have to use your multimeter to test to make sure everything is right. So the voltage you are receiving from the panels, the voltage you are getting from the grid, the voltage that is coming out of the system. Because you don't want a situation whereby there's an over voltage, you turn on the system, then it goes ahead to affect an appliance which is already being used in the house. We had to do all this. Now, upon doing this, we realized that the power coming from the grid was a bit high, and that was as a result of a loose connection with our neutral wire. So we resolved that, and then everything was correct. Aside from that, also there was an error, which is phase error. Now, phase error means that because we have 3 phases, one of the phases is either not configured properly, and we had configured exactly what was done by ECG, and we're still getting the error. So upon further trace, we realized that ECG didn't really follow the way they are supposed to do it. So if there's L1, L2, L3, it has to be in that pattern. So they had missed both L2 and L3, so we had to correct that. Then after that also, we ran into another problem. One of the breakers actually was giving wrong feed to the inverter, which was preventing power from the inverter from going into the house. Yes, so we had, and this was not our fault, this was actually the wiring which was done in the house. So we had to take time. So this actually system, which would have taken us a maximum of 2 days, took us 3 days to figure out everything. So we took our time to trace all the breakers, what the purposes that they were serving, where they were going, and all that. Then we were able to identify one particular breaker, because we had to turn off everything, then turn on one after the other to see what was the problem. Then we realized that there was a particular breaker which was providing power to a specific room, now the socket of the room, and the configuration was done wrongly. Instead of the earth serving the earth was connected to the live phase, and then the live was actually connected to the earth. So it was doing that wrong, and it was powered on, so it was sending wrong feed or signal to the inverter, which was preventing that from functioning. So we had to trace that. Now, upon carrying out some of these work, it's always good to have an electrician as part of it. And I must say, my electrician from PowerTech company has been one I have been working with for a very long time now, for almost all the projects that I work on. So he's an Energy Commission certified electrician in all the classes, that is domestic, commercial, as well as industrial. He's very good. So I highly recommend him for any electrical projects. So I've recommended him for some clients in the past, and they were very impressed by whatever work they went to do for them. So I highly recommend him. I'll put his contact also on the screen, so that in case you need any qualified electrician for your job, you can reach out to him. It's very important to take electrical works very seriously, because those are some of the things that starts fire in people's homes. So don't get anybody at all who's not qualified to do electrical work and then end up bringing you troubles. It's always good to go with somebody who is reliable. So he does both domestic, industrial, as well as commercial electrical wiring or configurations, among others. So there you have his contact on the screen. You can always reach out to him. And so like I said, it's always good to have an electrician as part of this, because he was able to trace all these errors that we're having, especially with the electrical works that was done with that is in the house. And once that was resolved, everything was working seamlessly. And at this point, you can see me testing the system, where I first of all turn off the PV to see it switching to the battery, that is switching to the grid. And then I went ahead to turn off the grid, and then it switches to the battery. So that is the kind of system that we have. And all this, like I said, is being done in real time. You don't have to go and turn this off, changes. No, you don't have to do anything. All this is being done in real time. And as part of the system, as part of it giving the main purpose of the configuration or the setup, which is backup, it is also going to help in saving electricity bills, in the sense that during daytime where you have a lot of daylight, the PV is working throughout, and the size of PV we have charges the battery quickly. I think when we tested, we first brought the battery was about 50%. When we turn on the PV, within an hour, the battery was fully charged. So we can say maybe in 2 hours, the battery is fully going to be charged if you have like a 0%, or even less, depending on how bright the sun is during that particular time of the day. So during the daytime, the panel provides a lot of power, so then you don't have to pay. So if you are paying, let's say, about 100 cedis at the end of the month, you're likely going to be paying like about 50 cedis or even less. And this is actually testimonies we've gotten from clients, and especially the one we did at the Oyarifa Park, because she now says that whatever she used to pay in terms of I think about certain amounts in thousands, has now reduced drastically, and that is as a result of the solar system in place. So you can see that solar system does a whole lot of things. After it's giving you convenience, it saves you money, it saves you the stress of wiring and the rest. Yes, it's very important. Now for this complete system, I'm sure you may be wondering how much did it cost to set it up. So the total cost for the system was 135,000 cedis. That included the cost of the battery, the cost of the inverter, the cost of the panels as well, and then all the accessories. So the accessories such as the rails, the clamps, that is the panel clamps, the roof clamp, then you have the cables, the 16 mm, you have to buy a coil of it, and then also the 10 mm, the coil of it, then a PV cable, also a coil of it, and then also you have the AC breakers, the changeover, the boxes, the trunking, all these accessories, as well as our labor cost, all inclusive, making a total of 135,000 cedis. Yes, so if you intend to have a system like this installed, you can always reach out to us. Yes, you have my details in the description of the video and even on the screen, and we shall be able to get you sorted out. No matter what kind of building you are in, we will definitely be able to tailor a solution towards your needs. Yeah, so in a nutshell, this is basically about the video. We installed a solar system for a client, and then also I must say maybe the cost now probably might reduce a bit because of the current fluctuations we are having in the dollar rates, which has, I think, brought prices of goods a little bit low. So when we did the installation, the price was not really low yet, so it hadn't really affected things. But now if you are thinking of doing it, I'm not sure you are going to spend the same amount for the same system that we've configured. So that will be just about it for this video. I think it's getting a bit lengthy. In case you have any questions or concerns or feedback or anything, you can surely drop them in the comment section of this video, and I'll try my best to respond to them. So thank you very much for watching, and I'll see you in the next one.